All right, we are covering Trig Unit 2, Day 4, Part 2, double trig functions again. But today we're going to do inverse trig ratios of trig functions. So the inverse is on the outside, the regular trig function on the inside. So inverse trig functions of trig functions. Here's an example. So regular trig ratio and then inverse. Trig function, a regular trig function returns a ratio. So we're going to say sine of some angle and get the ratio back. And then the inverse trig function will take that ratio and return an angle. And we're dealing with principal values here only. So remember that the angle that's returned will be the principal value angle. We'll separate this into two problems. If you can think of them as totally separate problems, that's best so you don't get confused. First you'll find the ratio of angle x. Really be better if I said theta. And then you're going to use that ratio as input to the cosine function to find your angle, the principal value angle. So let's look at an example, inverse cosine of sine of negative 45. So we do find the regular trig ratio. Negative 45 is the same as 315 degrees. Since my angle is in degrees, my answer will be in degrees, because remember, inverse function returns an angle as the answer. Okay, so we're going to draw a 45-degree reference angle and a 45-degree triangle in quadrant 4, which is going to give me an opposite of negative 1 and a hypotenuse of negative square root of 2. Sine is opposite of our hypotenuse, so this is our ratio. Don't rationalize. It's not our final answer, so we don't want to rationalize. It's just going to make things more confusing. Leave it as negative 1 over the square root of 2. Now we're done with that problem. We're going to start problem 2, which is what is the inverse cosine of negative 1 over the square root of 2? So again, well, we know the triangle because we got it from a 45-degree triangle, so our reference angle we know is 45 degrees. What is our angle? Well, remember, we're working with principal values. So it's a negative ratio, reference angle 45, and if we remember, cosine is negative in quadrant 2 for principal values. So we're going to have our 45-degree reference angle in quadrant 2, which gives us an angle of 180 minus 45, or 135 degrees. And that will be our final answer. This is actually an equal, it's not a negative here, so should be a positive erases. So this is an equals 135 degrees. Okay. I think the next page has something for you to try, so you should try that and check your answer in class to make sure you are doing this correctly. All right, another example. This one, notice we have the angle in radians, meaning that our answer will be in radians. Okay, so we've got 90 degrees. We want sine of 90. Sine is opposite over hypotenuse. And remember, we have our quadrantals 1 unit out. Coordinates are 0, 1. This is our adjacent. This is our opposite. So sine of 90 is going to be 1 over 1, which is 1. And we're done with that. Now we're going to pass that into inverse tangent. So inverse tangent of 1. And this time, especially with quadrantals, you need to be careful. So tangent, so remember, we'll put this ratio over 1. It's opposite over adjacent. So, and tangent is positive in quadrant 1. So we're going to draw a triangle this time. 1 over 1, 1, 1, square root of 2. It's actually 45-degree reference angle. So even though we started with an angle of 90 in the first problem, that is not the angle that we are going to be using, or that's not the reference angle for our second problem. So be careful. So reference angle is 45, tangent is positive in quadrant 1, so the actual angle is 45, and in radians it's going to be pi over 4, and that would be your final answer. For some reason I don't have it on here in radians. Okay, let's have you try another one. Again, this is your angle. First thing you want to do is convert to degrees. All right, we're going to try double trig functions on the calculators, and you just need to be careful because remember we've got reciprocal trig, inverse trig functions, and and the way that you use. So remember, regular trig functions for the reciprocals are going to be 1 over. Example, cosecant is equal to 1 over sine of x. For inverse, it's going to be, example's going to be inverse cosecant of x is equal to inverse sine of 1 over x. So it can get very confusing. You just need to keep your rules straight. So here's an example. This is probably the most difficult. Well, no, it's not the most difficult example. So inverse tangent of cotangent of negative 1.34. So start with this. You could put it all together as one command into your calculator, but it gets very confusing, so I recommend pulling it apart. Do this part. So this is regular, so it's going to be 1 over the tangent. And make sure we're in the right mode. So this appears to be in radian mode here. And you'll be told what mode you need to be in. So 1 over the tangent of negative 1.34. You get that answer, and then you're going to put it into the inverse tangent. And in this case, here's your answer from the cotangent. It's pretty straightforward. Just plug that answer right into inverse tangent, and you get your answer. You should try this one. Make sure you get the right answer. Okay, I'm going to try show you one more, I think. Again, I think we're in radian mode. Whoops, where the heck is this is just a repeat, isn't it? I guess it is. So one, I think, oh, yeah, that's a repeated slide. Here. This is what I wanted to show you. Okay, inverse cotangent of cotangent of 3. So again, this is just going to be 1 over tangent of 3. Make sure you're in the right mode. It appears to be degree mode. Radian mode, sorry. So I take that answer, inverse cotangent, but notice this is negative. So this is our special case. We have a negative ratio. We're taking an inverse cotangent of a negative ratio. So we're going to do inverse tangent of 1 over the negative ratio, and then we still have to add pi to this. So this is the type of problem where you're going to need to add pi or 180 depending on the mode, and you don't know ahead of time until you get the answer to the first question whether you're going to need to add your pi or not. So just be careful. Here is one for you to try. Bring any questions to class.